Welcome back to our channel. In today's video, we embark on a journey through nebulas, specifically talking about reflection nebulas. Today, we will understand what reflection nebulas are and what causes their magnificent colors. As with every video, before we begin, I invite you to subscribe to the channel and activate the bell icon to be notified every time a new video is released. Now, back to us. The light we receive from reflection nebulas is not directly emitted by the gas that constitutes them, as is the case with emission nebulas. Instead, the dust in these nebulas reflects the light of nearby stars. Thus, the light we see from these nebulas is reflected light. Hence the name reflection nebulas. Interstellar dust has nothing to do with household dust. Interstellar dust is composed of tiny solid particles. By tiny, we mean particles ranging from a few millionths of a millimeter to a few hundredths of a millimeter. These solid particles are primarily composed of carbon-based molecules, oxygen, silicon, and metals such as magnesium and iron. Interstellar dust typically forms on the cold surface of red giant stars or during the supernova explosions of massive stars. The reflection of light by dust grains occurs in a specific form called scattering. When light from a star near a reflection nebula encounters the nebula's dust grains, it is scattered, meaning it is reflected in different directions from the incident light. The blue component of the light that hits the dust grains is scattered more than the red component and is thus deflected more. Therefore, it is easy to understand why most reflection nebulas are blue. Simply because blue light is more easily scattered in all directions than light of other colors. Light of other colors, on the other hand, passes through these dust clouds more easily, being reflected less. This phenomenon is very similar to what causes the blue color of the sky here on Earth. In this case, of all the colored light that comes from the sun, the blue component is scattered more in all directions by the molecules that make up our atmosphere. As a result, from any point in the sky we look at, we receive blue light. Scattering ensures that, regardless of the color of the stars near the reflection nebulas, these nebulas appear blue to us. This is because it is precisely the blue light that is scattered the most. Obviously, if there are blue or azure stars near a reflection nebula, then the blue color of the nebula will be even more intense. An example of a reflection nebula is the NGC 7023 nebula, also known as the Iris Nebula. Within this nebula, which is about 6 light-years across, there is a cluster of young stars that have formed from the nebula's material. It is the light from these stars that is scattered by the dust grains of the nebula. The large amount of dust present in that area is indicated by the numerous dark clouds surrounding it. Another example of a reflection nebula is the Blue Nebula surrounding a very famous young star cluster, the Pleiades. This cluster contains about 1,000 stars, but its light is dominated by the presence of young, very hot, and luminous blue giant stars. The Pleiades cluster is located in the constellation Taurus and gets its name from the Greek word, pleion, which means, to sail. This is because the presence of this cluster in the sky during a certain time of year indicated a favorable period for navigation to the ancient Greeks. Its 9 brightest young stars are visible even under city lights and, according to Greek mythology, represent the 7 nymphs who were the daughters of the nymph Pleione and the Titan Atlas, who are also represented as 2 stars. The dust grains of the reflection nebula that envelops them scatter the light of these young stars. To be precise, it is not a single reflection nebula but a system of several reflection nebulas surrounding the stars. All these nebulas are part of one large cloud rich in hydrogen and dust that the Pleiades cluster has encountered and is passing through during its journey within the galaxy. It often happens that in the same region of the sky, both reflection nebulas and emission nebulas are observed, as in the case of the Trifid Nebula. Typically, this occurs in regions where stars are forming. The light from these young stars partially ionizes the interstellar hydrogen, which subsequently emits red light when it recombines, and partially is scattered by the dust in the nearby clouds. In the first case, typical red emission nebulas, called H2 regions, will form. In the second case, we will have blue reflection nebulas. As a final piece of information, reflection nebulas are typically classified as diffuse nebulas. That is, nebulas with no well-defined boundaries. This also applies to H2 regions and dark nebulas. That's all for today. In the upcoming videos, we will explore other types of nebulas together. We will also talk about the so-called molecular clouds, which are clouds where new stars form. If you want to learn more about nebulas, activate notifications to be notified when the next video is released. If you have something to say, leave a comment, of course after leaving a like and subscribing to the channel. See you in the next video.